All right, welcome to this recording. Notice here the dates are off. That's because of the events of last week, the snow, my absence, everything like that. So we're going to do a quick little review on radicals before we start our study on Pythagorean theorem, and which will lead us into our study on trigonometry. Okay, quickly, we know that the square root of a times b is equal to the square root of a times the square root of b. I call this, you can split a radical over multiplication. You cannot split a radical over addition or subtraction, just multiplication and division. Okay, so like this is part of what's called reducing radicals. And this is just some radical conversations that we're going to have ahead of when we have them in context with a math problem. Well, I know that 75 is equal to 3 times 25. So then I can rewrite this as the square root of 3 times the square root of 25. Well, I know that the square root of 25 is just 5. So this simplifies to 5 radical 3, or 5 square root of 3. We always put the whole number first outside of the radical. So this would come from outside to there. All right, now here, we can kind of do the reverse if we need to in the problem. These two items can kind of be almost combined, like they're like terms. So this would be the same thing as 2 radical 15. All right. This next conversation is a conversation we're going to have more. 46 divided by radical 2. We cannot have a square root in the bottom of a fraction. It's a mathematical rule. It is mathematical grammar. So the way we get rid of this is we rationalize the denominator. We multiply by radical 2 over 2. Radical 2 over 2 is 1. So therefore, it just kind of goes away. So now as we multiply the top of the fraction, 46 times radical 2 is 46 radical 2. Radical 2 times radical 2, just to have that conversation real quick, is equal to radical 4, which equals 2. So then we would have 46 radical 2 divided by 2, which is the same as 23 radical 2. Again, we will have all sorts of these conversations as we go forward. This is just a quick starter. Okay, here, if we look at our like terms here, our like terms are the 2 and the 5. Really what we have is we have 2 times 5 times radical 3, or 10 radical 3. Okay? Here, with subtraction, it's almost like combining like terms. So if we have 3 radical 6s and we take away 5 radical 6s, we have negative 2 radical 6. The same thing if you were to take like the square root of 7 plus 3 square roots of 7, you would have 4 square roots of 7. Here, kind of like, honestly, combining like terms. 2 times 4 and square root of 3 times the square root of 5. So here we would have 8 square root of 15. All right, so that's just some quick conversations on the arithmetic of radicals. These are 2 big ideas here. The third big idea is you cannot have a square root on the bottom of a fraction. All right, let's get in and we'll talk about Pythagorean theorem and its converse. This is a big review for you guys, so this should be no problem. Okay, used to find the missing length of a side of a right triangle. A and B are called legs. C is called the hypotenuse. For any right triangle, a squared plus b squared equals c squared. This is something you know. You've done this before. No big deal. So here we would have 8 squared plus 13 squared equals x squared. And as we go to our calculator, we would combine everything here on this side and then square root it. So let me flip to my calculator. Okay. So we would have 8 squared and 13 squared is 233 equals x squared. And then we go ahead and we square root both sides. So we get x equals the square root of 233. So the square root of the answer. 15.26. We need at least 2 decimal places here for accuracy. That's always a good way to start. And then on our next one, we're going to have x squared plus 7 squared equals 9 squared. 9 is the hypotenuse, so it's going to go after the equal sign. And then we're going to subtract over the 7 squared. And we're going to have 9 squared minus 7 squared. Gives us 32. And then we square root that answer for 5.66. Now, Pythagorean theorem is important because trigonometry is the study of triangles, and this is kind of the basic understanding of the side lengths of triangles, is that a squared plus b squared equals c squared. And we're going to use it for a lot of different items that we're learning here this year. Now let's go ahead and look at like a word problem. So a roofer has a ladder, okay? And it is leaned, a 16-foot ladder is leaned up against the base of a house. If the base of the ladder is 5 feet from the house, how high does it reach up? All right, so we've got our house, okay? Always draw a picture, it helps. We've got our ladder coming down this way. Okay, so this is 5 feet. The ladder is 16 feet. We're trying to figure out how far that is. So that's my crude right triangle. Okay, so we're going to have x squared plus 5 squared equals 16 squared. So here we're going to go ahead and subtract the 16 squared minus the 5 squared. Get 231. And then we're going to go ahead and square root the 231 and get 15.20. So we know that this reaches 15.20 feet up the side of the house. All right, now here's something important. It's the converse of the Pythagorean theorem. We can also use the Pythagorean theorem and side lengths of a triangle to determine whether or not a triangle is right, acute, or obtuse. Okay? The other thing we need to understand, for a triangle to be a triangle, the shorter two sides, A and B, must be bigger than C. So we got to check that first. Then if we want to talk about, so if we have C squared being less than A squared plus B squared, so if the hypotenuse is smaller than the sum of the legs, or the longer side, I guess it's not a hypotenuse technically because it's not a right triangle, we would have an acute triangle. If C squared is equal to A squared plus B squared, we have a right triangle. And then if C squared is greater than A squared plus B squared, we have an obtuse triangle. Okay? So C is always defined here as the longest side. So the first thing we need to check is are the smaller sides bigger than the third side? And then we need to check kind of the equality on the Pythagorean theorem here. So the first thing we're going to do is really here, we just got to kind of identify C. So C is 9 in this case. So if I take 3 plus 7, is that greater than 9? Yes. So this is a right triangle, or this is a triangle. Okay, now I have to take 9 squared and compare it to 3 squared plus 7 squared. So now if I go to my calculator and I take 9 squared and I compare it to 3 squared plus 7 squared, I know that 9 squared is bigger than 3 squared plus 7 squared. So 9 squared is greater. So since C squared, or the longest side, is greater, it's not equal, and it's not less than, we have an obtuse triangle. All right, let's check the second one here. 16 is my longest side, so it's going to act as C. So let's look at 4 plus 11 greater than 16? This is a no. So this is not a triangle. Not a triangle. These lengths cannot form a triangle. It cannot be a right triangle, cannot be an acute triangle, cannot be an obtuse triangle. It is not a triangle. All right, let's do the next example. Is 20 plus 21 greater than 22? Yes, this works. Now we're going to go ahead and 22 is our longest side, so that's going to become our C. So we're going to check, what is 22 squared compared with 21 squared and 20 squared? So let's go ahead and type this in our calculator, and we're going to compare it. So 20 squared plus 21 squared is greater than 22 squared. So you can go ahead and see that. So let's go ahead, and we know that the 20 squared plus 21 squared is greater. So therefore C squared is less, and we have an acute triangle. Okay? All right, now 17 plus 17 and 22. So is 17 plus 17 greater than 22? Yes, so it is a triangle. Now let's go ahead and we're going to identify our longest side as 22. So we're now going to go ahead and check, how is 22 in comparison to 17 squared plus 17 squared? So let's go ahead and do this. So 22 squared, 17 squared plus 17 squared is 578. So 578 is greater. So this is great. So the 17 squared plus 17 squared is bigger than 22 squared. So we have an acute triangle. So this is the converse. All right. There are some practice problems for you to look out here, and you can work together.